Look up at the night sky from anywhere in America, from the deserts of Arizona, the mountains of Colorado, the suburbs of Texas, or the skyscrapers of New York, and you'll see something that feels infinite. Thousands of stars scattered across a black canvas, maybe the faint band of the Milky Way stretching overhead. It feels vast, it feels endless. But here's something almost no one stops to ask: if the solar system is shaped like a flat disk, like every textbook and classroom poster shows, then what's above it? What's below it? If the planets orbit in a neat, flat plane around the sun, what lies beyond that plane? Is there empty space? Is there structure? Is there something wrapping around us right now that we simply can't see? The answer is far more profound than most people realize. Because once you step outside the familiar planetary disk, you don't find emptiness, you find enormous spherical clouds of icy objects, magnetic bubbles larger than imagination can hold, shock waves from ancient stellar explosions, and structures that connect our sun to the entire Milky Way galaxy. We are not floating on a simple flat diagram. We are embedded inside layers upon layers of cosmic architecture. And once you see it clearly, you will never look at a solar system diagram the same way again. If you enjoy deep, calm explorations of the universe like this, consider subscribing and supporting the channel. It truly helps. And before we continue, I'd love to know, which part of the United States are you watching from? Drop your state or city in the comments. It's always incredible to see where curiosity is coming from. When most people picture the solar system, they imagine something very clean and organized: the sun in the center, 8 planets orbiting in a thin, flat plane, maybe with a few asteroids between Mars and Jupiter, and perhaps Pluto drifting out beyond Neptune. It looks almost like a vinyl record spinning in space. This image is not wrong, but it is incomplete. The reason the solar system appears flat is rooted in its birth approximately 4.6 billion years ago. Before there was a sun, before there were planets, before there was Earth, there was a vast cloud of gas and dust floating in a region of the Milky Way galaxy. This cloud, called a molecular cloud, was composed mostly of hydrogen and helium, with traces of heavier elements forged in earlier generations of stars. Something disturbed this cloud. Perhaps a nearby supernova explosion sent a shockwave through it. Gravity began to pull the material inward. As the cloud collapsed under its own gravity, it began to spin. Even a tiny initial rotation would increase dramatically as the cloud shrank. This is due to the conservation of angular momentum, the same principle that causes a figure skater to spin faster when pulling their arms inward. As the cloud became smaller, it spun faster, and as it spun faster, centrifugal forces caused it to flatten. This flattening is unavoidable in rotating systems. When a cloud of material spins, particles collide with each other. Over time, vertical motion, movement above and below the main rotational plane, cancels out. The result is a thin, rotating disk. This structure is known as a protoplanetary disk. At the center of that disk, most of the mass accumulated into what would become the sun. The remaining material in the disk gradually clumped together into planetesimals, then protoplanets, and eventually into the planets we recognize today. Because they formed within this flattened disk, the planets orbit roughly in the same plane. That plane is called the ecliptic, but roughly is important. The planets are not perfectly aligned. Mercury is tilted by about 7 degrees relative to the ecliptic. Pluto's orbit is tilted by 17 degrees. Even Earth's axis is tilted by about 23.5 degrees relative to its orbit, which is why we experience seasons. The solar system is mostly flat, but not perfectly so. Now here's where things become more interesting. The flat planetary disk represents only a tiny fraction of the solar system's true structure. It is the densest and most visible part, yes, but it is surrounded by regions that extend vastly farther and in all directions. Imagine shrinking the planetary orbit so that Neptune's orbit fits inside a coin. In that scale model, the next major structure, the Oort Cloud, would extend miles away in every direction, not in a disk, not flat, but spherical. Before we reach the Oort Cloud, though, we must address another misconception: the idea of up and down in space. When we say above or below the solar system, we are speaking from a human perspective. On Earth, up means away from the ground, down means toward it, but in space there is no universal up or down. The solar system's disk is simply oriented at a particular angle relative to the Milky Way galaxy. If you were an alien living in another star system, your OP might be completely different from ours. In fact, The entire solar system is tilted about 60 degrees relative to the plane of the Milky Way galaxy. That means the disk of the planets is not aligned with the galaxy's disk. We are orbiting the galactic center at roughly 500,000 miles per hour, while tilted like a spinning coin moving along a massive racetrack. So when we ask what exists above and below the solar system, we are really asking what lies beyond the thin planetary disk in all directions perpendicular to it. The first answer lies in the Kuiper Belt. Beyond Neptune, extending roughly from 30 to 50 astronomical units from the Sun, is a region filled with icy bodies. Pluto resides here along with thousands of other objects. The Kuiper Belt is still somewhat disk-shaped, though thicker than the interplanetary plane. It represents leftover building material from the solar system's formation. But beyond the Kuiper Belt, the geometry changes dramatically. Far beyond Pluto, perhaps as far as 100,000 astronomical units from the Sun, nearly 2 light-years away, lies the Oort Cloud. Unlike the flat planetary disk, the Oort Cloud is believed to be spherical. It surrounds the solar system like a vast shell of icy debris. If the inner solar system were the size of a small coin, the Oort Cloud would form a sphere the size of a continent. This spherical shape likely formed because early gravitational interactions with passing stars and the tidal forces of the Milky Way pulled objects into more random, inclined orbits. Over billions of years, the originally flatter distribution of icy bodies became isotropic, meaning equally distributed in all directions. The Oort Cloud is thought to be the source of long-period comets. When a nearby star passes close enough, or when galactic tides disturb this distant shell, icy objects can be nudged inward. Some of them fall toward the Sun, becoming the bright comets we occasionally see streaking across the sky. So above and below the solar system's flat disk lies not emptiness, but an immense spherical swarm of frozen relics from the birth of our Sun. But the Oort Cloud is not the end. Beyond that lies interstellar space. But even that is not empty. The Sun is constantly emitting a stream of charged particles called the solar wind. This wind flows outward in all directions, forming a giant bubble around the solar system known as the Heliosphere. The Heliosphere is shaped somewhat like a teardrop as it moves through the galaxy. It acts as a protective shield, deflecting many high-energy cosmic rays from outside our system. The boundary where the solar wind slows down and meets the interstellar medium is called the heliopause. Spacecraft like Voyager 1 and Voyager 2 have crossed this boundary, entering true interstellar space. Above and below the planetary disk, the heliosphere still extends. It is not flat. It is a three-dimensional structure surrounding us completely. We are inside it right now. Beyond the heliosphere lies the Local Interstellar Cloud, a region of slightly denser gas and dust through which our solar system is traveling. And beyond that lies the local bubble, a cavity in space carved by ancient supernova explosions millions of years ago. In other words, when you leave the flat diagram of the planets, you do not find emptiness, you find layers. Spheres within spheres, bubbles within cavities, structures formed by gravity, magnetism, radiation, and time. And this is only the beginning. The solar system is not an isolated island. It is embedded in the galactic disk of the Milky Way, orbiting its center once every 225 to 250 million years. Above and below that galactic disk lies the galactic halo, a vast, roughly spherical region filled with ancient stars, globular clusters, and dark matter. So the question, what exists above and below our solar system, unfolds into something much larger. Above and below the planets lies the Oort Cloud. Beyond that lies the heliosphere. Beyond that lies interstellar space. Beyond that lies the galactic structure itself. The flat solar system diagram is a simplification. Reality is three-dimensional, layered, dynamic, and deeply interconnected. The Oort Cloud, the heliosphere, and the cosmic environment that cradles our Sun as it journeys through the galaxy. Because once you understand what surrounds us, the idea of up and down becomes less about direction and more about perspective. We now leave the comfortable orbits of the 8 planets. We move past Neptune. We drift beyond the Kuiper Belt. And we enter a region so vast that it challenges the limits of imagination. A region that does not lie in a neat plane, but instead surrounds us in every direction like a cosmic shell. This is the Oort Cloud. Unlike the planetary system, which is flattened into a disk, the Oort Cloud is believed to be spherical. It does not sit above or below the solar system. It envelopes it. If you could somehow zoom far enough away from the Sun, you would not see a flat vinyl record shape. You would see a tiny bright center surrounded by an enormous, faint sphere extending possibly up to 100,000 astronomical units away, nearly 2 light years from the Sun. To understand how extraordinary that is, consider this: Neptune orbits at about 30 astronomical units from the Sun. The Kuiper belt extends to perhaps 50 astronomical units, but the inner boundary of the Oort cloud may begin thousands of astronomical units away. Its outer edge could be over 2,000 times farther than Neptune. In scale, the planetary region is just a grain of sand at the center of a continent-sized sphere. The Oort cloud is thought to be composed of trillions, possibly even quadrillions, of icy objects. These are remnants from the solar system's formation, leftovers that never became planets. In the early days of the solar system, the giant planets, especially Jupiter and Saturn, acted like gravitational slingshots. As they formed and migrated, they flung enormous numbers of smaller icy bodies outward. Some were ejected completely into interstellar space. Others were pushed into extremely distant, elongated orbits. Over millions of years, gravitational influences from passing stars and the tidal forces of the Milky Way altered those orbits further. What may have once been a more flattened distribution gradually became randomized. Objects were pulled into orbits tilted at every conceivable angle. The result was a spherical swarm. This is why long-period comets can approach the Sun from any direction. Unlike short-period comets, which tend to orbit within the plane of the planets, long-period comets often dive inward at steep angles, sometimes even perpendicular to the planetary disk. Their origins are consistent with a spherical reservoir. But here is something remarkable: we have never directly observed the Oort cloud. No telescope has imaged it. No spacecraft has reached it. Its existence is inferred from the behavior of comets and from mathematical modeling. It is one of the largest structures in our solar system, yet it remains completely invisible to us, and this invisibility carries an important lesson. The solar system is not defined solely by what we can see. It extends into realms that are dark, sparse, and nearly undetectable, but still gravitationally bound to the Sun. If we continue outward, we encounter another structure, not composed of icy bodies, but of energy. The Sun is not a quiet object. It constantly emits a stream of charged particles known as the solar wind. This wind flows outward in all directions at speeds of hundreds of kilometers per second. It carries with it the Sun's magnetic field, creating a magnetic bubble around the solar system. This bubble is called the heliosphere. The heliosphere is not flat. It does not follow the plane of the planets. It expands outward in 3 dimensions, forming a protective cocoon around our system. As the solar wind travels outward, it eventually encounters the interstellar medium, the thin gas and dust that exist between stars. At a certain distance, the outward pressure of the solar wind is balanced by the inward pressure of the interstellar medium. This boundary is called the heliopause. It marks the edge of the Sun's influence. Voyager 1 crossed the heliopause in 2012, Voyager 2 followed in 2018. These spacecraft, launched in 1977, have now entered interstellar space. They are still within the Sun's gravitational influence. They have not escaped the solar system entirely, but they have passed beyond the solar wind's protective bubble. The heliosphere itself is shaped somewhat like a comet. As the solar system moves through the Milky Way at roughly 500,000 miles per hour, interstellar gas presses against the front of the heliosphere, compressing it. Behind the Sun, the heliosphere stretches into a long tail. This means that, above and below, the solar system's disk are not empty regions. They are filled with streaming particles, magnetic fields, and the subtle interaction between our star and the galaxy. The heliosphere plays a crucial role in protecting life on Earth. High-energy cosmic rays constantly bombard the galaxy. Many of these rays are deflected or slowed by the heliosphere's magnetic field. Without this shielding effect, the radiation environment near Earth would be far more intense. Our planet's atmosphere and magnetic field provide additional protection, but the heliosphere acts as the first line of defense. Beyond the heliosphere lies the Local Interstellar Cloud, a region of slightly denser gas through which our solar system is currently traveling. This cloud is not uniform. It contains variations in density and magnetic structure. The Sun likely entered this cloud tens of thousands of years ago and may exit it in the distant future. Even beyond that lies something even larger, the local bubble. The local bubble is an enormous cavity in the interstellar medium spanning perhaps 300 light-years across. It is believed to have been carved out by multiple supernova explosions millions of years ago. These explosions blasted away gas and dust, leaving behind a region of lower density. filled with extremely hot plasma. Our solar system sits inside this bubble. That means above and below the solar system's disk lies not only a spherical cloud of icy debris and a magnetic bubble of solar wind, but also a vast cavity formed by the deaths of ancient stars. The implications of this layered structure are profound. The solar system is not an isolated flat disk floating in emptiness. It is embedded within a hierarchy of structures. First, the planetary disk. Second, the Kuiper belt. Third, the spherical Oort cloud. Fourth, the heliosphere. Fifth, the local interstellar cloud. Sixth, the local bubble. Seventh, the galactic disk. Eighth, the galactic halo. Each layer surrounds the one inside it, and we have not yet reached the largest scales. The Milky Way galaxy itself is a flattened spiral disk about 100,000 light-years across. But above and below the galactic disk lies the galactic halo, a roughly spherical region populated by ancient stars and globular clusters. The halo also contains vast amounts of dark matter, an invisible substance that exerts gravitational influence but does not emit light. Our solar system orbits within the galactic disk about 27,000 light-years from the galactic center. As we orbit, we bob slightly above and below the galactic plane over tens of millions of years. This vertical oscillation may even influence long-term comet activity by altering gravitational perturbations in the Oort cloud. So when we ask what exists above and below our solar system, the true answer spans from icy comet reservoirs to magnetic shields to interstellar clouds to galactic architecture. There is no sharp boundary where the solar system ends. Instead, there is a gradual transition from gravitational dominance to magnetic influence to interstellar blending. And perhaps the most humbling realization is this: every layer we have discussed is invisible to the naked eye. The night sky does not reveal the heliosphere. It does not show the Oort cloud. It does not display the local bubble. Yet we are inside them all. The diagram in textbooks, the tidy disk of planets, is like showing a single cell and ignoring the organism around it. It is a simplification useful for learning, but incomplete for understanding. Above and below the familiar plane of the planets lies structure upon structure, each shaped by gravity, motion, magnetism, and time. Each tells a story about our origins and our connection to the galaxy. And perhaps that is the deeper lesson of this exploration. We often think of space as empty, but emptiness in the cosmic sense is relative. Even the most rarefied regions contain particles, fields, and history. The space above the solar system is not nothing. It is part of a dynamic, evolving environment that links us to exploding stars, drifting interstellar clouds, and the rotation of an entire galaxy. When you look up at the night sky from anywhere in the United States, whether from a rural field or a city rooftop, you are not looking out from a flat island. You are looking through layers of cosmic structure. And every one of those layers extends both above and below the thin disk of planets that we once thought was the whole story. By now, the idea of above and below our solar system has begun to dissolve. What started as a simple geometric curiosity, what exists above the flat disk of the planets, has expanded into something far larger. We discovered that beyond the planetary plane lies the spherical Oort cloud. Beyond that lies the heliosphere. Beyond that, the interstellar medium. Beyond that, the local bubble. And beyond that, the Milky Way itself. Now we step even further outward, because the Milky Way is not the final layer. Our galaxy is a barred spiral structure roughly 100,000 light-years across, containing hundreds of billions of stars. The Sun orbits within one of its spiral arms, not at the center, not at the edge, but somewhere in the middle distance, about 27,000 light-years from the galactic core. The entire solar system, along with everything we have discussed, is carried along on this orbit at astonishing speed. But even the Milky Way has an above and below. If you could travel millions of light-years away and look back at our galaxy from the side, you would see that it too is a flattened disk, a glowing spiral structure with a central bulge. And just like the solar system, that disk is surrounded by a spherical halo. This galactic halo contains ancient stars, globular clusters, and a vast amount of dark matter. It extends far above and below the bright spiral arms. Dark matter, though invisible, dominates the galaxy's mass. Without it, the outer stars would not orbit as they do. The halo's gravitational influence holds the entire structure together, and our solar system moves within this larger gravitational framework, carried along like a microscopic passenger on a massive rotating platform. But the Milky Way itself is not alone. It belongs to a collection of galaxies known as the Local Group. This group contains more than 50 galaxies, including the Andromeda Galaxy and the Triangulum Galaxy. The Milky Way and Andromeda are the two largest members, slowly moving toward each other. In about 4 to 5 billion years, they will collide and merge, forming a new elliptical galaxy. Above and below the galactic plane, in every direction, lie other galaxies. They are not randomly scattered. They are arranged along enormous filaments of matter, forming what cosmologists call the cosmic web. These filaments stretch across hundreds of millions of light years, connecting clusters and superclusters of galaxies. Between the filaments are vast cosmic voids, regions where very few galaxies exist. If you zoom out far enough, the universe begins to resemble a three-dimensional network, like a neural structure or a web of light. And here is the crucial realization: there is no preferred direction. When we asked what lies above and below the solar system, we were thinking in terms of orientation. But orientation depends entirely on perspective. In space, there is no universal up or down. There is only position and motion relative to other structures. The solar system's disk is tilted relative to the Milky Way's disk. The Milky Way is oriented at an angle relative to other galaxies. The local group is moving relative to the cosmic microwave background radiation, the faint afterglow of the Big Bang that fills the universe. Everything is in motion. The Earth rotates on its axis at about 1,000 miles per hour at the equator. The Earth orbits the Sun at about 67,000 miles per hour. The Sun orbits the Milky Way at about 500,000 miles per hour. The Milky Way moves within the local group. The local group moves relative to the Virgo cluster. And all of it expands outward as the universe itself expands. So what is above us? Above us is interplanetary space. Above that is the Oort Cloud. Above that is the Heliosphere. Above that is the interstellar medium. Above that is the galactic halo. Above that are neighboring galaxies. Above that is the cosmic web. And beyond that, as far as we can measure, is more universe. But in truth, none of it is above or below. It surrounds us. When astronauts aboard the International Space Station look at Earth, they do not see a planet with an up and down. They see a sphere suspended in blackness. If you were floating in deep interstellar space, far above the ecliptic plane, you would not feel above. You would feel weightless, directionless, immersed in a universe without orientation. This realization has philosophical implications as well as scientific ones. Human beings evolved on the surface of a planet with gravity pulling consistently in one direction. Our brains are wired to think vertically. We build structures upward. We dig downward. We speak of heaven above and the underworld below. But the cosmos does not share our vertical framework. When we project above and below onto the solar system, we are imposing Earth's experience onto a reality that is fundamentally different. And yet, the question remains meaningful, because asking what lies beyond the flat disk forces us to expand our mental model of the universe. It forces us to recognize that simplified diagrams are not the full story. The true structure of our cosmic environment is layered, spherical, dynamic, and interconnected. There is another profound insight hidden here. The solar system's flatness tells us about its origin. It formed from a rotating cloud. The galaxy's flatness tells us about its origin. It formed from a rotating collapse of matter in the early universe. These repeating patterns, rotation, flattening, gravitational binding, appear at multiple scales. But the universe as a whole does not flatten into a single plane. On the largest scales, it appears statistically uniform in all directions. There is no cosmic up, no cosmic down, no center, no edge that we can detect. Observable universe extends about 46 billion light years in every direction. And no matter where you stand within it, it appears roughly the same on large scales. This is known as the cosmological principle, the idea that the universe is homogeneous and isotropic when viewed at sufficient scale. In other words, it has no preferred direction. So what exists above and below our solar system, everything stars, galaxies, has dark matter, radiation, structure, history, and space itself. And nothing, no edge, no ceiling, no floor. Just layers of reality extending outward until distance and time blur into the unknown. There is something quietly humbling about this. For centuries, humans believed Earth was at the center of everything. Then we learned Earth orbits the Sun. Then we learned the Sun is one star among hundreds of billions. Then we learned our galaxy is one among trillions. Each step removed us from the center. But it also placed us inside something far more magnificent. The fact that we can map the heliosphere, model the Oort Cloud, measure galactic rotation, detect dark matter's influence, and observe galaxies billions of light years away is extraordinary. We are tiny, yes, but we are aware, and awareness gives scale meaning. When you look up at the sky tonight, from California or Florida, from Illinois or Washington, you are looking through layers of cosmic architecture that extend both above and below the planetary disk. You are looking through the heliosphere, through interstellar space, toward the galactic halo, into the broader universe. The solar system is not a flat island floating in emptiness. It is a node within a vast, three-dimensional cosmic network. And perhaps the most powerful conclusion is this: asking what lies above and below is not just a scientific question. It is a perspective shift. It reminds us that the diagrams we learn as children are stepping stones, not final truths. Reality is richer than the illustration. The solar system's flat disk is real, but it is only one layer. Surrounding it are spheres, bubbles, clouds, halos, filaments, and voids, structures shaped by gravity, radiation, motion, and time across billions of years. And beyond all of it lies the open question that has always driven exploration: what have we not yet discovered? Because just as the Oort Cloud was once unimaginable, just as the Heliosphere was once theoretical, just as galaxies beyond the Milky Way were once unknown, there may be further layers still waiting to be understood. Our species has existed for only a fraction of a second in cosmic time, and yet, in that brief moment, we have traced the structure of our solar system far beyond its flat plane. Above and below are human words, but the universe does not recognize them. It simply expands in every direction. Thank you for taking this journey.